When we are multiplying the polynomials, the best way to do that is using the box method because you can do this problem in an organized fashion. So in our first parentheses, we have two terms, so that's 4x and 5. So that's going to be either the two columns or two rows. It doesn't really matter, so you just decide which one you prefer. So I'm going to write that as my two columns. So I have 4x and then plus 5. And then in my second parentheses, I have three terms, so those are going to be my rows. So I have x squared minus 2x and then plus 5. And now what I'm going to do is I'm going to take each term, so from each row, multiply that by 4x and the 5. So let's take x squared, multiply by 4x, and that's going to be 4x to the third power, because when you multiply, you add the exponents. So 2 plus 1 is 3. And then x squared times 5 is going to give you positive 5x squared. And now you do the same thing, take the second term, negative 2x, multiply by 4x again, and that's going to give you negative 8x squared. So again, add the exponents when you multiply, so 1 plus 1 is 2. And then negative 2x times 5, that's going to give you negative 10x. And last one, 5 times 4x is positive 20x, and then 5 times 5 is going to give you positive 25. And the last step to multiplying polynomials is to add the like terms. So in our case, like terms are typically listed diagonally if you use the box method, or the table method. And so I'm going to add my x squares together, and then I'm also going to add my x's together. Those are the like terms. So my final answer to this problem is we have 4x to the third power, and then negative 8 plus 5, that's going to give you negative 3x squared. 20 minus 10 is going to give you positive 10x, and then you just bring down the 25. And that's how you multiply using the box, or sometimes we call that the table method. It doesn't matter. So now we're going to do the same thing for the next problem, except that instead of you have two columns and three rows, this time you're going to have 3 rows and 3 columns because each parentheses has 3 terms. So again, I'm going to rewrite the problem. So we have negative 3x squared plus x and then plus 3. And then for the second one, write it vertically. So you have 3x squared minus 2x and then plus 6. So now again, I'm going to take one row at a time. So take 3x squared multiplied by negative 3x squared, and that's going to give you negative 9x to the fourth power, because when you multiply, add the exponents, 2 plus 2 is 4. 3x squared times x is going to give you positive 3x to the third power, because there's an invisible 1 for the exponent x. So 2 plus 1 is 3. And then 3x squared times 3 will give you positive 9x squared. So now let's take the negative 2x, and we're going to do the same thing. Negative 2x times negative 3x squared will give me positive 6x to the third power, because there's an invisible 1 again for the exponent x. Negative 2x times x, that's going to give me negative 2x squared. And then negative 2x times 3 will give me negative 6x. So now I'm going to take my last term 6 and multiply again. So 6 times negative 3x squared will give me negative 18x squared. And then 6 times x will give you positive 6x. And my last term is 6 times 3 will give you 18. And again, the last step to multiply polynomials is to combine like terms. So combine all the red ones together because they all have x to the third power. Combine the green ones together because they all have the x squared. And the last one is combine all the x's together. So now my final answer to this problem is negative 9x to the fourth. And 6 plus 3, so we have 9x to the third power. Negative 18 minus 2 is negative 20 plus 9. So that's going to give me negative 11x squared. And 6x plus negative 6x or 6x minus 6x will give you 0. So there's no more x's. So you just bring down the 18. And that's the solution for this problem.